For years, metal 3D printing has let engineers build complex shapes that traditional methods can't create. This process uses a laser or electron beam to melt metal powder, fusing it layer by layer. However, rapid heating and cooling often leave behind microscopic cracks and weak points, limiting the strength of printed parts. These flaws are a challenge for industries like aerospace and medicine. Manufacturers need metal components that are lighter, stronger, and more durable, but standard 3D printing often falls short. Scientists have developed a new approach. Instead of starting with metal, they first print a delicate hydrogel or polymer lattice using light. This skeleton offers precise control over the internal structure. The soft lattice is then soaked in a solution that gradually deposits metal onto each surface. As the metal builds up, it exactly copies the original design. Once the template is removed, what remains is an ultra-fine metal architecture with far fewer defects and much greater strength. Tests show these grown metal parts can be up to 20 times stronger than conventionally printed ones. This could lead to lighter aerospace components, better heat exchangers, and durable medical implants. The technique is still new, scaling up, ensuring consistency, and controlling costs will take more time. Yet growing metal may transform how we design and build structures, from tiny devices to major components.